You've already learnt about water pressure. Can you explain how water pressure changes now? Now and now. If you recall what you learnt about water pressure, then you will remember that the pressure exerted by a column of water increases as its height increases. Potential difference is the difference in the electric potential between 2 points of a conductor. What is the relationship between potential difference and the amount of current? Would it be the same as in the case of water flowing? Answer this before proceeding. Potential difference has a lot in common with water pressure. To examine the relationship between potential difference and the amount of current, we will need a circuit in which we can change the potential difference. Look at this simple circuit, which has an electric cell that creates the potential difference. The readings shown on the voltmeter and ammeter are 0.2 volt and 0.1 ampere respectively. Now, let us connect a second cell and note down the readings. The readings are 0.4 volt and 0.2 ampere respectively. Now we will connect a third cell and again note the readings. The readings are 0.6 volt and 0.3 ampere respectively. Look at the ratio of V to I. V stands for the potential difference between the 2 points measured in volt. I stands for the amount of current measured in amperes. If we plot a graph of V against I, it will look like this. The graph shows that the ratio between V and I is a constant ratio. I, the electric current flowing through a metallic wire, is directly proportional to the potential difference V across its ends, provided its temperature and physical dimensions remain the same. This is known as Ohm's law. Ohm's law is named after a German physicist, George Simon Ohm. He was able to define a relationship between voltage, current, and resistance that represented the beginning of electric circuit analysis. The expression V by I is a constant for a given wire at a given temperature. This constant is known as the resistance of the conductor. It is measured in ohms. In the SI unit, it is denoted by the Greek letter omega. So what does 1 ohm mean? If the resistance of a conductor is 1 ohm, then the potential difference across the two ends of a conductor is 1 volt, and the current passing through it is 1 ampere. What will happen to the flow of current if the resistance is increased or decreased? If resistance is increased, less current will flow. And if resistance is decreased, more current will flow. This is so because resistance is inversely proportional to the current. The ammeter in the circuit shows this change. Resistance is different for different conductors. The lesser the resistance, the greater is the flow of electricity. The greater the resistance, the lesser is the flow of electricity. Good conductors will have lower resistance. Bad conductors will have more resistance. Insulators will have the highest resistance. Resistors are those devices that offer a level of resistance. They are used to limit the current flowing through sensitive components. Now, let us calculate the current flow in a 100 ohm resistor that is connected to a 20 volt supply. We know the resistance and the voltage. By applying Ohm's law, we can find out the flow of current. By substituting the values, we get the current as 0.2 amperes. Next, calculate the voltage supply needed to produce a current of 11 amperes when used with a 45 ohm resistor. If the current produced is 11 amperes and the resistance is 45 ohms, then by applying Ohm's law, we can calculate that the voltage needed is 495 volts.